Hello, everybody. Hi. So, if you didn't see the last talk that I was in, my name is Glenn. This is me from a previous version of this conference. I think I had just done a magic trick. That's what it looks like. And I am today talking about Aspire. I believe there was some problems with the agendas because James and I changed the title and the content of our talk 1,432 times. 43, I think, actually. And poor Nacho struggled to keep up. So this is what we were talking about. My goal today, I know a lot of you didn't put your hands up when I asked in the previous session how many of you are using Aspire, but let's start that this time. Everybody has to participate. Okay, hands up if you have tried out Aspire a little bit, like just done like file new. Okay, excellent. Okay, and then put your hand up if you have not tried it at all. Good, excellent. Now put your hands down. And if you have heard about it but do not understand what it is for, put your hand up. Okay, wow, there's so many less hands for don't understand what it was for. That's amazing. Historically, there would be many more. Okay, let's then start in the beginning. So you heard me in the previous talk a little bit about our inspiration for Aspire. So I'm going to spend some more time on this first part because so many of you aren't using Aspire. But then after that, I'm going to go pretty deep into how Aspire achieves some of these things. So some of it might be a little bit like hard to follow just because you're super unfamiliar with it. I'll do my best to change that on the fly since so many of you haven't used it, and then we'll see where we go. But what I really want to do is leave you with the right mental model, the right brain cannon, for lack of a better word, for how it is that Aspire fits together, because that'll help you a lot when you do start in your journey, should you decide to do so. So the first thing I'm going to do is run, I just created this Aspire new project on this machine using the Aspire templates. This is what it looks like when you run it. And so in this case, the default Aspire app has a dashboard, it has a web front end and an API service. And so when you go to the dashboard, which I believe we saw a little bit of for James at least, it then shows you every part of your app. So if you've got web front end, API, database, say, if you're going standard, or you've got, 4 UIs, 40 backend microservices, 20 different databases and caching technologies, they would all appear in this dashboard as one go. And we have many examples of big, complex projects running on this. Lots of internal teams are picking up Aspire. What you get in here is you can start to see a graph. So this graph will show you all the connections between all the pieces of your application. You then can see, of course, the best new feature is this icon right here. See this little icon? It's the best feature because I did it. Other than that, doesn't really matter. Then you have console logs. So all of the logs for your application for every different app will appear in here. You have structured logging. So structured logging is all of those logs, but you can search and you can do things like show me all requests where status code greater than 400 to get like 400, 401, 404, right? Things like that in your structured logging. Then we have what people really like, which is often distributed traces, which I have none of because I've not hit the app at all. But if I navigate around a little bit, then you start to see distributed traces. So these, look at that, connect. What these things let you do is view how long all the individual requests to your application are taking, and it shows you each amount of time spent in each individual piece. So you can see at a glance which things are going slow and why. Whose fault is it? Which service is slow? Which database call was slow? Where is all my time going in this request? Or where was the error? In this case, we're not really doing much, so there's not much happening as of interest. This is what they look like. So in this case, the overall request took 140 milliseconds. 20 milliseconds overall was spent in the web front end, but like 5 milliseconds of that was getting the data. So we know in this case that the perf here, even though this isn't very slow, was not in the API, it was mostly in rendering. It was in displaying the data is what this chart would tell you. Right? And if you had a slow database or something like that, it would show up here really obviously because you would see this big chunk for like database call. Other things that are interesting here is there's this sample application we have that has lots of microservices in it. It's called eShop. It uses Aspire. And when we were converting that sample app over to use Aspire, we opened up this chart. What we realized is that one of our pages was making like 50 distinct database calls, like one after another, for no reason. Like it did not have to do that at all. And just no one did, because it was just an app that we were messing around with, nobody had realized that that was the case. And we were like, oh. But it was one of our initial moments of just how having this kind of thing at a glance can just highlight things that you should go and work on in your application. So yeah, you run Aspire, local dev, it'll spin up everything that you need, all your database. So it supports Docker, executables, and projects. So if you're going to put a cache, an output cache on your web app so that all of your like rendered HTML is cached and fast, you can run here, it'll spin up the Redis container in using Docker, then it'll do service discovery between those, so you don't have to deal with how to connect your different pieces together. So one of the things that we wanted to do when we started this project was to make it so that connection strings disappeared, that you should not have to care about them. Connection strings were for code. You as a dev you should never have to care what the connection string is, what the format of the connection string is. That connection strings website that has 1 billion connection strings for every single database on the planet shouldn't be required anymore. Things like that is one of our goals. And so it has service discovery built in, but it's a service discovery based upon config. So let me make this a little bit more real for you by showing you what this looks like. So in the app host, this is the code that makes those two apps run. So you can see we have add project for my backend API, this API service. Then we add this web front end, and we're saying we're adding health checks. So by default, there's a lot of not conventions. Aspire has some opinions. And those opinions are, you shall use OpenTelemetry. We turn it on by default. It's always there. Anything that you add as an Aspire component is already configured to use OpenTelemetry by default. You shall try to there will be health checks available. You don't have to use them if you don't want, but they will always be there because they probably need to be. And for some of the deployment options, they kind of get used automatically by the platform. So you might not use them or care about them, but they do get used even. In this case, we're explicitly exposing them here. You will use resiliency patterns. So there is a default resiliency pattern built into Aspire. So when this web app calls this backend API, it is doing it with a retry pattern, with exponential backoff with randomization, and a few it's basically we extracted it from Teams actually, from the Teams team, the people who make the Teams application, their resiliency patterns for all the backend APIs to make sure the team doesn't go down, which they're mostly successful at. We baked that in as your first default, as the default. You can change all of these, but by default, you got that. Which means that if you have some transient temporal failure, your API goes down for 100 seconds, your app won't even notice. It'll just keep going. That's the default that we wanted to bake in. We wanted to make it so that if you didn't know anything, if you had never used the cloud before and you didn't know all of the pitfalls of setting all this stuff up, that we could give you as good a start as we could. That's what Aspire is about. And it's about doing it in such a way that you can have a similar dev experience that you've always had when running your application. Okay? So, I'm going to now jump into something else. And this is gonna be hopefully okay. For somebody who has not really looked at Aspire much or only knows a little bit about it, come to me afterwards and tell me how much of this made sense. I want to know. Somewhat experimental in this talk format. So what the Aspire conceptually is made up of resources. So in that project that I just showed you, there was an API project resource, which was the backend API. There was a front-end resource, which was the web. There was two project resources, web and API. That's the easy way to say that, okay? And they were connected together. So that's what Aspire is. It's a collection of resources. Your app model project is defining what resources you have and the relationships between them. If you want to be super computer science-y, then it's a heterogeneous directed acyclic graph, which means that all of the resources can connect together and those connections are directed. So there is a direction to that relationship because A depends upon B, but B does not depend upon A, right? So my web app can depend upon my backend API, but my API can't then also depend upon my web app, which means your relationships are directed. That's what directed acyclic graph means. So that's what that is. So you build this graph of all the different resources and all the different relationships. You saw it on the web page for a minute when I clicked graph and it just had the two bubbles in the drawer. That's drawing the graph, right? And then this example on the screen is the types of resources, the types of things in here. If I was to add Redis, it would look like this. And then each of those resources has a collection of configuration, like the connection string for it, what port is it? Ports. We wanted to make ports disappear, was the other thing that Aspire was for, so that you didn't have like port is already bound, I'm already listening on port 5000, things like that. So then that configuration of, okay, what ports you're using, what the connection strings are and such, they are all bundled up in that resource. And then when we run the application, set all those things as environment variables, basically. So when you deploy, you set environment variables with the same name as what we use in dev, and then everything just keeps working for you. So Aspire is a collection of resources. It then has two different modalities. You have run mode, which you saw me when I did Aspire run, which runs the app on your dev machine. It takes that collection of resources and it runs it. I'm going to talk deeply about how that works in a moment. And then you have publish mode, which is where lots of people get confused, where it takes that same application, that same graph, and it generates an asset that goes to some location. So that might be Bicep to go to Azure. It might be, what is the AWS one, CloudFormation? It might be Terraform. It might be Docker Compose, right? To be able to go to many different places in the end. Because what the app host becomes is your source of truth for how your application is structured, the relationships between it, and all of the things that you're going to need to be able to do that deployment. We started out in Aspire trying not to solve deployment. We didn't want to. We wanted it only to be dev mode. And the further we went, the further we realized that we couldn't, because otherwise it would not solve the problem enough to actually achieve the gains that we wanted to gain. And so you don't have to use the deployment part still. If you've already got some deployment thing, you can absolutely just start using Aspire and only use dev mode, and just when you're going to deploy, you deploy the same way you always have. Because there's nothing special about an Aspire app. Like the projects that are in your Aspire app aren't different to any other .NET application that you have ever run. They're just configured to use OTel and use this particular environment variable for the connection string that it's going to read and such, things like that, which you would have done anyway. You just would have done it with your own convention. So there's nothing like magic about an Aspire application other than it's pre-configured for a few things that you would need to know about, right? Which can feel magical, but it's not really. Okay, so how does dev time orchestration work? What does Aspire do? So Aspire has this thing called the developer control plane. You will probably never have to worry about what the developer control plane is, but the thing we're experimenting with today is how much you actually understanding some of the details helps you figure out what this Aspire thing is about. So what the developer control plane is a little executable that comes with Aspire or Visual Studio or however you've acquired .NET, and it exposes the Kubernetes API. So you can actually use like a Kubernetes client to talk to it, except it's built for Aspire. Like it's custom built to expose a Kubernetes endpoint. And what it does, it has the ability to launch executables, to launch containers, to launch dotNET projects, and orchestrate them in the same way that Kubernetes does, but only on one machine. It has no concept of how to cluster. All the complexity of Kubernetes is how to like handle many, many machines all networked together. This thing is just for your machine, for nothing else. It's for development, right? And so it knows how to run all of your stuff. And so the Aspire app host just is giving information to the developer control plane in order to be able to run your app. How does it do that? Now, more computer science-y bullshit. Okay, that's how. So, lowering. Aspire, as my architect will tell me, is a compiler, because all good computer science projects can be solved by writing a compiler. In a compiler, lowering is when you take a high-level concept, like a for-each loop, and then you rewrite it into some simpler thing, like a for loop. So instead of, you could imagine that the C# compiler, it doesn't actually do this, but you can imagine a world where when you write a for-each, the compiler just turns the for-each into a for, right? Because they're the same. So then the language, like the runtime, doesn't actually know anything about how to do a for-each, it only knows how to do a for, right? And that way, the compiler allows you to get the productivity gains of this higher level language construct, but the runtime is simpler, and it doesn't have the complexity of actually having to implement and understand those higher level constructs. This is what the concept of lowering is in programming language, like compiler design, right? That's what Aspire does. The app host is your higher level construct. It is your human readable like understanding of how your application is structured. And then the Aspire project, when you do Aspire run, it lowers it into IL, same as how C# goes to IL. And that IL is the IL is different depending upon where you're going, basically. So in the case of what suite am I on? Yeah. So in dev time orchestration mode, you have your .NET app host, right? You're that C# code we just saw. It gets lowered into a very specific format for talking to DCP, which is actually this like it uses the Kubernetes client API to call. So each one of those like resources turns into a call to a DCP. So it gets lowered down into this DCP format. And then the developer control plane takes that specific DCP format and it knows how to run containers and executables and projects and stuff, right? So it's like a compiler, it's the same as a compiler project. And why is that important? Because it allows a bunch of other things to happen. So this is the extended diagram that I just showed you. And it seems super complicated, but don't worry, don't let that scare you. All this is saying is Aspire app host gets translated into this lowered into this DCP format. DCP then knows how to allocate endpoints such that you never have port problems because it is in control of what all the ports are, right? So DCP decides on your ports. Although that's not technically true. You can pass port information comes in from like where you would expect to define it today, but it will take the ports you've given if you give them. Otherwise, it will allocate it. It does the networking Docker stuff to be able to like run your dependencies or like Podman. It'll just run exes for you. It'll launch the dashboard. It'll monitor everything. It'll try and keep it up when it's running on your machine, right? This is what DCP does. So DCP is the magic that lets you do local development with Aspire, right? So why is that interesting? Why do we do this like weird tangent onto computer science-y stuff? Because if we exit here and we go in here and we say Aspire, well, we can't do this yet. We're going to go Aspire add. Okay, so Aspire add lets you add a new NuGet package, but it filters NuGet packages to those that are owned by the Aspire account on NuGet.org, assuming my network loves me. So it's okay. If this works, otherwise this will be difficult for me to I'll just have to describe what it is supposed to happen here. What happens here is it finds packages that are Aspire only, like they're owned by the Aspire account. And then I'm going to add in Visual Studio, if you right-click and you say Add Aspire Compact Component, I think it is, or integration, I can't remember the exact word we used, I think integration, it does the same. So like Visual Studio already has this thing that I'm doing on the CLI here. Right, and then if I search for like container, so I add this app containers package, right? What I'm adding here is in Aspire's, I guess I should show you what that did. So when I did that Aspire add, what happened is it just added a NuGet package. Like it's not super fancy. It just added the app containers NuGet package to my app is all it did. It's just a way to filter NuGet to only ones. Okay, we should go on this tangent because so many of you weren't familiar with Aspire. There's a thing called Aspire integrations. What Aspire integrations are extensions for Aspire, like they're in that NuGet package that I just added, the Redis NuGet package, right? They pre-configure the thing that they're for to work within the opinions that I described earlier. So when you use the Redis integration for Aspire instead of the normal just default Redis client, Stack Exchange Redis or something, the Aspire version adds Redis client library to dependency injection. It sets up it knows the right lifetime for DI. It makes sure that the OTel is wired. OTel is wired up so that you see Redis in the OTel graphs. It hooks up the resiliency pattern to the client so that it is using the right resiliency pattern when you're communicating with Redis, and then gives you extension methods to add that client in. So you can go app.addRedis in your web app, and it does all of what I just described. That's what an integration is. So it's just the same Stack Exchange Redis. And it's not a new Redis client. It's the same Stack Exchange Redis that you always would have used. It's just configuring it. Because when we started Aspire, we had this slide. And it had, on one side, it had the steps required to add Redis to your application in a good, production-ready, resilient way. And it had 15 bullet points on it. And there's one line now, which is add Aspire. We said we're going to make those 15 bullet points add Aspire. That's what those integrations are. We have two versions of them, client integrations and server integrations. Server integrations are the thing I just described, where you add a dependency. Client integrations is just the other half. They're hosting integrations versus client integrations. Hosting integrations is when you add it here. So let's just do some of this. Now we're going to pray to the internet gods for me. If we add Redis, I'll show you. So the hosting integration is the thing you put in the app host that actually launches Redis. And then the client integration is the thing I described to you where it adds it to DI and it configures the client for you, right? So if we add Redis here, does that make sense? So integrations, two parts. One, host, that tells it how to run the Redis image. Tells the app host how to run the Redis image. Then you have client, which is how to configure the client to talk to that Redis, to that thing. Set up with all of the right packages. So when I say, var redis equals builder.add, right, add Redis, and I give it a name, if I can type, and I give it a name, hello. This is using a hosting integration. Move off of that so that the IntelliSense. So this add Redis is the hosting integration. It has some config in it, and I'll show an integration later, a custom integration, so you'll see a little bit of how this works, what it is. All that really is, in that extension method is it adds, we talked about a resource earlier, it adds a Redis resource type to the graph that we described, and attached to that resource is information like, what is the Redis image name that I'm supposed to run when I actually run this thing? And that's kind of it. Then if I go to the other half of this, if I go over to my web app and I was to go and add Redis in here, then I would need to add the client integration and then call add Redis here, and that would add the client to DI that points to it. And I would use the name hello as part of service discovery to make sure that those two things were the right thing. Right? So I can show you that. And and make sure that it lands a little bit before I show you publish. Where are we? So actually, let's do. We added the other thing. Let me show you publish first, and then we'll come back to this. So var env equals. I'm going to say builder dot ACA Azure Container App Environment. Okay, so we talked about lowering earlier. And then we talked about why is lowering important. The reason it's important is what this line does. This is me saying in my app host, one of the places I'm going to deploy to is Azure Container Apps. You can deploy to multiple. We have one for App Service, we have one for Docker Compose. They're in preview, but we can show them. Then now, so by default, by just adding this, then if I come out here and I say aspire publish, and I say .out.pub, right? What happens is aspire takes the app host and lowers it to bicep because it knows that I want to publish to ACA. So if those of you who are using Azure, how many people are on Azure versus Azure? AWS? Your own internal, like servers in your environment? Okay. Google Cloud? All right. Tencent, Huawei. Okay, we'll keep going. Okay, cool. So Azure was the most common there still, but there was a spattering of AWS, a spattering of everything that I asked somebody put their hand up for, other than maybe the Chinese ones. So what happens now is I have this .pub, and I wanted to do that so that I could make sure those of you who weren't familiar with Azure understood what this was. So in this .pub folder, you can see I now have this main bicep file, which is kind of orchestrating my deployment. I have a bicep file for each resource. So for those of you who haven't used Azure or aren't using bicep, this is the Azure specific file that you would give to the Azure deployment experiences to go and create things on Azure and configure them. So this is, I'm struggling to remember the AWS file format name. There is an extension for Aspire that supports the Amazon one as well. But if you were to go to AWS instead of container apps, instead of adding the container apps package, you would add the AWS package. It'll have an AWS environment method that's exactly the same as this. Then you will get a completely different file format when you do publish, because it'll be all specific to AWS. If I had Docker Compose and do Docker Compose instead, it'll generate a Docker Compose file that has all the same things that my app host had in it. So the reason lowering is important is that it makes this ridiculously extensible to where we can go. Because we can take that app host file format and compile it to any type of output. Taking a particular language format and compiling it to multiple outputs, my engineering team can do the shit out of that job. That's their job. That's what they do. They are the people who passed their computer science class really well and then did that stuff for a living, as opposed to most of the rest of us who never had to worry about a linked list properly for the rest of our lives, right? So that makes us super extensible because we can go to multiple locations. So that's how Aspire Publish works. It lowers the app host into these intermediate formats. If you were using the AZD, the Azure Developer CLI, it actually automates a lot of this. It just goes straight there. You do AZD up, and it's just suddenly in the cloud, right? But under the covers, it's doing what I just described. It's taking this app host, it's figuring out how to turn that into bicep, then it's taking that bicep, and it's running it. And then if you were going anywhere else, you would do the same thing. Oh, the other thing I was going to call out, in here, so what you can see as we navigate through the web front end, there's hello. Look at that. That's my Redis container called hello. As you look at the config required for these, see all these environment variables that are kind of automatic in here. So it's automatic. It's configuring all of the. Okay. When I talked about service discovery and making connection strings disappear, this is how we did it. So, when on your local machine, you do Aspire run, you have a web app, talks to your API. That API gets spun up, and then whatever the port is that it got spun up with gets added, the full URL, gets added to an environment variable called services API services HTTP 0. It's a naming convention. There'll be a HTTPS one, and there could be many of these. It's a particular format. You can Google the format for it. So if you were to deploy this manually, then that's what you would have to set. Like if you were to run this on a server yourself and set it up and do all your own deployment, that's the only real detail, is that by default, unless you specify your own environment variable names, that's what it's going to look for, is that format. And that's how service discovery works. We just made up environment variables and we set them on the fly. Because DCP is in charge of running you, and because we control the thing that's going to run you, we know we can set all those environment variables. That means you don't have to worry about ports, you don't have to worry about connection strings. It means that when the new developer comes to your machine and he clones your repo and he does a Aspire run, then it just works. The database runs because the database is a container, so you didn't have to spend 3 hours trying to figure out how to install SQL Server. You didn't forget the magic environment variable that everybody has to set that's not documented anywhere yet because it gets done for you because everything is in the app host. And if anything is not in the app host and you're using it to generate deployment artifacts, then it won't work because you're not deploying it. So like the more you tie into the app host, the better this gets, but it doesn't force you to. You can just eject at any point and only use bits and pieces of it. You can even just use the individual Aspire packages if you want. If you just want to use the service discovery, if you just want to use the resiliency defaults and just grab the integration and use it outside of an Aspire project, you could even make that work if you really want to, even as like a tiny little element. Because we didn't want to create like a big box where everything only worked if it was all put together. But we do believe it's something that absolutely is greater than the sum of its individual parts. So when you use them all together, the experience gets really good. And the amount of time saving that we see people get from using Aspire is kind of ridiculous. It's also why it's being picked up more and more and more internally at Microsoft. Every week we seem to have another internal team who has decided to run some new service using Aspire. Run's a bad word because they're not running it using Aspire, but developing it. And that meant we had to do a lot of work. The other reason that Aspire is very extensible is that all of those first-party services. So Microsoft services. If you're building a service at Microsoft, it's not running on like Kubernetes vanilla most of the time. There's just like a bunch of stuff. We have a bunch of internal systems and services that these things use. They all have their own integrations. So you add the logging integration for the way Microsoft internal logging system works, for example, right? Some Microsoft services are just running on Kubernetes, but there's a lot that aren't. They have their own custom infrastructure. And then we have that environment line, ACA, we have custom environments for the other different places that you can run internally. So we have all of our own customized, we've used all the extensibility points of Aspire to build our own productivity stack for our own internal developers in order to be able to be more productive for themselves. Because I talked earlier in the keynote, if you saw, about my role as a steward of .NET as an ecosystem for you all. Another element of my role is to try and make sure that .NET is that there's so much .NET at Microsoft. That means that the other part of my role is to make sure that those developers who are at Microsoft are ideally more productive than any other developer at any other company if they could possibly achieve it, right? So we try and do that with things like Aspire as well. Okay, so that was an interlude into Aspire Publish and extensibility. And so the reason that I talked about all of that computer science stuff about lowering and things like that is because I'm hoping that by having a smattering of this idea that like the app host turns into some kind of intermediate thing and then it gets like pumped out to different outputs, helps solve the well, I don't understand deployment, well, how does that work? What's going on? And then also lowering helps make Aspire extremely configurable. It gets modified at multiple layers. There are multiple different ways that it can get outputted. It can go to any cloud. It can go to all these places. So that is why that lowering concept. That's why I threw it in there. And so wherever you are deploying your app to, we might not have a built environment for it to get to like make it easy right now. But I am confident that you could make an extension that will make it work. Right? Because we've done some crazy ones in order to prove out the extensibility points. Okay, so let's go back then to an app. So now with our newfound knowledge, you understand that this add Redis adds a resource, like an iRedis resource, to a graph. You know that add project line, API service, add project, that's adding another resource. And then the third this line 10 is adding another resource. You know that because what this with reference does is it adds what's called an annotation, which is just data on the resource, to the web front-end resource, which ultimately just turns into an environment variable called API service, HTTP, blah, 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 that thing you saw in that main bicep file. And then when you run this, it takes this project generates a DCP, like a calls to the developer control plane, and the developer control plane is responsible for spinning up each of these things, making sure that all the ports are there, and running all the things, right? Cool. That is probably not clear at all, but hopefully it was helpful to at least some of you. Okay, so then let's talk through a bit more of a more detailed extensibility example. By the way, especially for all those who were like, I haven't used Aspire yet, if you want to get more of a getting started with Aspire version of this, I absolutely have the getting started with Aspire talk that we can give. This is not that talk though. If we Aspire run this sample. So this Aspire samples repo, if you want to play along at home, github.com/.net/aspire-samples is where this is. All of this code is on GitHub. Launch failed. Oh, I don't have the right .NET installed on this machine. That's going to make it annoying because the internet won't be fast enough. Okay, so what this app does is it runs how many of you use health checks? Okay, have you used the health checks UI? Okay, is Luis here? The health checks UI project is made here in Spain because it's made by some folks from Plain Concepts. .NET, if I can type, health checks UI. It's on GitHub. It's a project. It's a project that. Oh, that's not the one that I wanted. I wanted GitHub, not NuGet. It's on NuGet. It's on GitHub. What it does is give you a dashboard for all of the services in your app. Is there a screenshot? There it is. Okay. So it looks like this. And some of the folks that work on this are probably here, actually. They might be here. They're probably here at the conference, at least. It's an open source project. It's not part of .NET. It's just a thing that is out there in the .NET OSS ecosystem. It gives you this dashboard saying, here's all your services, here's all the different, here's the status of them all. It's like a monitoring dashboard for all the different health checks, right? It's really cool. But there was a problem. The problem is that, and we talk about this in the README, the problem is that the health checks, we don't by default expose. When you run Aspire, there is multiple health checks endpoints. There's one that just says, am I healthy, yes, no. That one's good. There's another one that gives you all the details. Now, we put that one on a different port because we saw lots of people accidentally pumping all those details out into the world. And so it's on a different port that's not really exposed by default. So that was not obvious to people how they were supposed to make this health checks UI work, because it needed all those details to be able to draw that screen with all those interesting things. And so what we created in this samples repo is how to do that, which is this is basically showcasing extensibility points of Aspire for how you can make something work. So we had several problems. One is several, but probably only a couple. One was, how does the health checks UI project, the container that is running the health checks UI dashboard, it needs config that lists all the URLs that it's going to check for health checks, right? Because it's going to list them all in a list. Yeah. Then I also need the actual endpoint, the thing that gives the health check information, exposed so that that thing can actually call it, and then point that thing, for that config, right? So it has those two problems. And so what we have is just this method. It says add health checks, and you say with reference, and that's it. It works. If I had .NET 8 on this machine, because we haven't upgraded this to the thing yet, then I would be able to run it right now and I would show it to you. So we made this work, but this doesn't work by default. As I just said, we had to make this method. So now if I go to definition of add health checks UI, it does two things. Here's this word resource again. We have this type called health checks UI resource. So this is a class that inherits from a thing called container resource, which we have inside Aspire. So that's how you implement your own custom resource type that sits within that graph that we talked about earlier, right? So you create a class. In this case, it's just a little bit of, we just give it the URLs. We give it some config information, like where the probe paths and stuff. It also specifically has this collection, which is custom, called monitored projects, right? So we add this custom resource to the graph, and then these builder methods here, we say add resource to the custom resource. Then we give it the with image registry and such. They are how you configure that resource to run. So that's all the information DCP needs to run it. So this image is the Docker image tag, so it's like docker.com, Docker. The registry is like Docker.io. The image name is like the name of the image on Docker Hub, and then this is in configuration for like where it's these with environment is specifically config information that project needs, like the container needs to run, and then there's port information. So if you have some Docker image. Well, let's say you're in a world where there's some other team, and they work across the street in a different building. Therefore, you're not allowed to talk to them to ask them any questions because they live across the street. And you could create a custom resource for their component if you wanted to. You would get them to publish a Docker image, say some internal private registry. You go create a resource for their image. You write this code. Then you can say add, across the street team's resource. And that's it. That's all you would do. And then it would work, right? Or if you didn't need it you don't need it technically to be a custom resource just to do that. You could just do this by calling add container resource, because if it's really just a container, you probably don't need a custom resource, but you could if you wanted to. Then we add this thing called lifecycle hooks. So lifecycle hooks are how you get to inject code into the lowering process that we described earlier. So the lifecycle hook is a class, and it has all these methods like before start, before endpoint allocated, after endpoint allocated. It's just got a bunch of methods, and we call each of those methods as that lowering process converts the app host into the format for wherever it's going to go. This allows you to customize any part of that pipeline by just manipulating that model as it comes in and goes out. So this gives you almost complete power to just manipulate things as you will. So what we did for this health checks UI is in this life hook, before everything starts, we find the health checks resource. So this is the dashboard container. Then we get all the monitored projects. So what we did to make that work is whenever you do with reference, that adds that project to the monitored projects collection. It's just like a trick to make it so that we didn't have to go and look up all the projects again here. You could imagine here saying, okay, now go find all the references and search through the projects, and this is just a thing to avoid doing that. Then we check whether or not the health endpoint exists. This is that health check endpoint that we said was on a different port because it has more information. And if it's not there, add it. So this is turning on that health check endpoint for people automatically. Then we down here we do the get the config, and then ultimately set this health checks UI URLs, environment variable, which is all the URLs that health checks UI needs to be able to go and hit every one of those health endpoints to get all that information back to render that dashboard that you saw earlier, right? And then when it's in publish mode, it has a different thing. So one of the other things that you can do in Aspire is in here you can say like if publish mode, do something different to if dev mode. So for example, you might only want some of your dependencies on your local machine when you're running and not have them be part of the deployment process. And you can do that by putting an if statement in here, okay? And that's how this kind of extensibility works. So this add health checks UI uses a lifecycle hook and a custom resource to completely change the app as it goes through the lowering process, right? And so this sample is up online. You can go like explore it if you want to. I could talk you through it more if you like. I could wait 12 minutes for the .NET version to download to be able to run it for you, but I'm not going to do that. Then, but the main point that I wanted to land here is you have Aspire creates a graph of resources in the app host. Then it has two main ways: dev mode, where it turns that graph into DCP, and publish mode, where it takes that graph and converts it to whatever it needs to be able to go to the environment that you configured in here. You can also, in here, you can also, if I go back, sorry, I should have this one open. You can also say with environment, ACA. Env, I call it env, not ACA. I could also not with environment, what did we call it? With compute environment, that's right. So you could also say with compute environment and what that lets you do is have each service you could independently deploy to a different environment. So I could add, say, AWS here. I could say underneath var env, I could say var ACA equals ACA, var, I don't know, app service functions AWS equals, add one of those. And then I could say API, go to ACA, front end, go to app service. And then when I do publish, I will get a mix of those two output formats because the lowering process works, right? So the point that I wanted to land was it is ridiculously flexible in its extensibility should you wish to do it. So lots of people get caught up in this idea that, all the demos that I've seen are AZD up because that's super easy, so we demoed that a lot early on. But I'm not using Azure, or I'm not using container apps yet, or I've already got a whole bunch of stuff. Why would I don't understand how I can take where I am right now and get it to the thing you just described to me, even though I lack the look of the thing. And so I wanted to land for you all that I am confident you can do that, whatever the thing is, because we've done it a lot for various projects. And if not, it's probably a bug that we have to go fix, in which case I want you to tell me what those bugs are as well so I can go and fix them. So that was my intent, to try to give you a mental model of how Aspire works, how the resource model works, and how it gets converted into these multiple file formats, and how the extensibility, how flexible and extensible it is. Hopefully I was successful at that. If you have more questions, because you're super new to this stuff, feel free to come talk to me. I'm going to be around. I'll be here for James's talk that is coming up, but I'll also be around a little bit, so feel free to come talk to me. Hopefully this was useful and entertaining and informational to you. Thank you very much.